Brown adipose tissue, BAT, represents one of the most striking examples of how fat can function not as a passive energy depot but as a metabolically active organ dedicated to thermogenesis and systemic energy regulation. While white adipose tissue, WAT, stores excess energy, brown fat burns it, transforming lipids into heat through a process known as non-shivering thermogenesis. This function, once thought relevant only to infants and small mammals, is now recognized as a lifelong feature of human physiology, with brown fat depots detectable in healthy adults and modifiable through environmental and lifestyle factors. Its presence challenges conventional narratives around fat as inherently harmful and instead points to a future where activating thermogenic fat could be a viable strategy for enhancing metabolic health and longevity. At the molecular core of brown fat's unique function lies uncoupling protein 1, UCP1, a mitochondrial protein found almost exclusively in brown and beige adipocytes. UCP1 uncouples oxidative phosphorylation by allowing protons to re-enter the mitochondrial matrix without producing ADP. This short-circuiting of the electron transport chain leads to the release of energy as heat, a process that consumes fatty acids and glucose, increases energy expenditure, and contributes to body temperature maintenance. Importantly, this mechanism is not wasteful. It is a finely tuned response to cold exposure and other metabolic signals that helps preserve core body temperature without the need for shivering, which is energy-intensive and unsustainable over long periods. In infancy, BAT plays a life-saving role. Newborns, who lack sufficient muscle mass for effective shivering, rely on brown fat depots in the neck, shoulders, and spine to generate heat and survive cold stress. For a long time, it was assumed that this capacity disappeared with age. However, modern imaging techniques, particularly PET-CT scans, have revealed that brown fat persists into adulthood in distinct anatomical locations, such as the supraclavicular area, around the spine, and in the perirenal region. While its volume declines with age and increased adiposity, BAT remains inducible in adults, especially through repeated cold exposure, exercise, and certain dietary components. The metabolic benefits of BAT go beyond thermal regulation. By actively consuming circulating triglycerides and glucose to fuel thermogenesis, brown fat helps reduce blood lipid levels and improve insulin sensitivity. Studies in humans have shown that individuals with higher BAT activity have lower fasting glucose, improved glucose tolerance, and a healthier lipid profile compared to those with less or no detectable brown fat. These findings suggest that BAT acts as a metabolic sink, clearing excess nutrients from the bloodstream and converting them into heat, thereby protecting against hyperglycemia and lipotoxicity. Moreover, brown fat's calorie-burning capacity has potential implications for weight regulation. While the total mass of BAT in adults may be modest, its high metabolic rate per gram allows it to make meaningful contributions to daily energy expenditure. Some estimates suggest that fully activated BAT could burn hundreds of kilocalories per day, an amount equivalent to moderate physical activity. More importantly, brown fat activation can shift the balance of energy flux, making it more difficult to accumulate excess fat, even in the presence of a calorie surplus. This thermogenic advantage positions BAT as a promising target for anti-obesity interventions, particularly in populations with reduced energy expenditure due to sedentary lifestyles or metabolic disorders. The discovery of beige adipocytes, thermogenically competent fat cells that emerge within white adipose tissue in response to specific stimuli, has expanded the therapeutic potential of thermogenesis even further. Beige fat shares many characteristics with classical brown fat, including UCP1 expression and mitochondrial density, but arises from different precursor cells. Factors such as chronic cold exposure, SS-adrenergic stimulation, exercise, via myokines like irisin, and dietary compounds, e.g. capsaicin, resveratrol, and catechins, can promote the browning of white fat, effectively converting it into a metabolically active, heat-producing tissue. This plasticity suggests that the body's thermogenic capacity is not fixed, but modifiable, a trait that could be harnessed to counteract age and obesity-related metabolic decline. In aging, the decline in brown fat activity and mass may partially explain the decreased basal metabolic rate and increased susceptibility to weight gain and hypothermia observed in older adults. Interestingly, some evidence indicates that individuals with preserved BAT function into old age may maintain better metabolic health, more stable body temperatures, and lower inflammation. This raises the possibility that supporting brown fat activity could be a lever to promote healthy aging. Environmental strategies like controlled cold exposure, such as cold showers or intermittent exposure to cooler ambient temperatures, may help preserve fat function over time. Similarly, exercise and polyphenol-rich diets may sustain beige fat formation and mitochondrial health, preserving thermogenic capacity into later life. In sum, brown adipose tissue exemplifies the versatility and potential of adipose biology. Far from being a vestigial remnant of infancy, that persists in adult life as a metabolically protective, thermogenically active organ. Its ability to burn fat, regulate glucose, and generate heat positions it as a vital component of the body's energy homeostasis and thermal defense. By embracing a more nuanced understanding of fat, one that includes its thermogenic and regenerative capacities, we can move away from the simplistic fat is bad narrative and toward a more sophisticated appreciation of adipose tissue as a key player in systemic health and longevity. Brown fat, once overlooked, may well be one of the body's most powerful natural tools for resilience, balance, and long-term vitality.